Good afternoon. Today I'm going to talk about the observation of Mesospheric front over the Brazilian low latitudes. This work was developed in Federal University of Campina Grande, Paraíba State in Brazil. The first mesospheric ball was observed by Taylor in 1995 during the Aloha campaign, and after that, with the development of the air glow cameras, several work have been published reporting the mesospheric front from the equatorial latitude up to the high latitude. This phenomenon consists in a sharp wave followed or not by a train wave that can propagate for long distance into the ducts. Immediately after the first observation by Taylor, a couple of papers published by Dewan and Picard in 1998 and 2001 was dedicated to explain the origin and the propagation of the fronts in the MLT, and including the complementary pattern that can be observed in the short movie here. For example, here we have observation of two mesospheric fronts in two locations at different time. The left panel shows the observations for São João do Cariri. The right panel shows the observations for Monteiro. The bottom image shows the O8, the front observing the O8 layer, and the top image shows the front observing the OI5577. For example, here we have the propagation of the front to the east, and a different complementary pattern was observed. For example, for São João do Cariri, we have observed dark and dark front followed by train wave, while for the Monteiro we observed a bright front in the O8 and a dark front in the OI5577. Those patterns basically indicate the altitude where the duct is located. For example, if the duct is above the emission, we have the enhancement in the brightening of the images. If the duct is located below of the layer, we can have a dark pattern in the air glow image. After basically two decades of observations and modeling on the mesospheric front, some important questions were not answered up to now. For example, how does a front interact with the background, producing atmospheric instability and secondary waves? What are the source of the mesospheric front, and how is the temporal variability of them? How does the wind system act in propagating of the front producing filtering process? Which other atmospheric phenomena interact with the mesospheric front? For the present work, we aim to contribute to investigate the long-term variability in the occurrence of the mesospheric front in the equatorial region. When the observation started, this front was classified as a rare event. So, our observations was done in São João do Cariri. It is located at 7.4 degrees south, 36.5 degrees west. It is located in the equatorial region in the northeast of Brazil. Here in this picture you can see the area of the observatory. Here we have the build of the observatory, and a total of 2,972 nights were observed, which correspond over 7,000 hours of observation. As a result, we investigate the occurrence of Mesospheric front as a function of the year. In this chart, we can see that the Mesospheric front are not rare as thought initially. For example, we could observe Mesospheric front in all years and uh, for example in 2018 2019 10 Mesospheric fronts were observed. If we investigate the temporal variability of the Mesospheric front as a function of the months, we could see, for example, that in March and April we could not observe Mesospheric front, while in September 13 Mesospheric fronts were observed, indicate that they preferentially occur in those periods of the year in the equinox month. In the equinox month around September. In this case, we separate the occurrence of the plasma bubble as a function of the seasons, and we can see here that there is a clear enhancement of the occurrence as a function of the season. Of course, the season for the south hemisphere. We have here more mesospheric front appearing during the spring and less mesospheric front appearing during the summer. One important thing to investigate the origin and the filtering process on the mesospheric front is the propagation direction. Here we have a polar plot showing that the most of the observed mesospheric front were propagating to the northeast direction, north around the top, and you have several waves propagation to the southeast and south. On the other hand, if you observe it here from to the east and west, few mesospheric front was observed, indicated that something happened here. Either the source of the fronts were not located along the east-west line, or there is some kind of filtering process that are not allow the propagation of the wave in this direction. Another interesting thing is investigate the temporal variability of the propagation direction. We did separating the propagation direction of the wave according to the season, and you can see, and you can clearly see that, for example, during the summer, most of the wave is propagating to the northeast. However, if you compare to the fall, the propagation of the waves were concentrated to the north and the southwest. When you go to the winter, most of the wave is propagating to the southeast, and in the spring we have some fronts propagating to the northeast, southeast, and south. In summary, from 2011 to 2021, more than 59 mesospheric front was observed in the regular image over São João do Cariri. The temporal variability of the fronts we're investigating. The main results are based on the observation. The fronts were not so rare in the equatorial region, since they could be observed every year, and in some years more than the 10 events were observed. In March and April, mesospheric front was not observed, while in September was the month with more occurrence. The occurrence of the fronts increased from the summer to the spring. A clear anisotropy in the propagation direction of the fronts was observed with a preferential propagation to the northeast, southeast, and south. The anisotropy pattern changes with the season. Thus, these results suggest that either the source or the filtering by the wind system could be the reason for the change in the anisotropy. I would like to thank to the Federal University of Campina Grande that paid my registration fee to participate of this conference. I'd like to thank also to Fundação de Amparo à Pesquisa do Estado da Paraíba and Conselho Nacional de Desenvolvimento Científico e Tecnológico for funding my research. Thank you for your attention.